You know, we've always been told that gray hair is just an inevitable part of getting older. But what if I told you that every single one of those silver strands is actually a badge of honor, a sign that your body just won a microscopic battle? Okay, let's get into it.
Right? You see it in the mirror and you just think, well, time's catching up. For decades, that's been the story. Simple as that. But what if those gray hairs aren't a sign of decay at all, but a sign of defense? Turns out that's exactly what some new science is suggesting.
You've heard me right. Some of the most cutting-edge research is now showing that going gray isn't just about aging. It might actually be this incredibly sophisticated defense mechanism, a trade-off your body makes to protect you from something way, way more dangerous: cancer. So let's really unpack this surprising idea. It all comes down to this critical decision our stem cells have to make. Do they create color or do they protect the body? And understanding that choice, well, that's the key to this whole story. The secret sauce here is a process called seno-differentiation, and that's a term that comes from researchers at the University of Tokyo. Now, think of it like cellular self-sacrifice. When a stem cell that makes pigment gets some DNA damage, instead of risking becoming a tumor, it just matures, colors one last strand of hair, and then gracefully bows out. It disappears. And this slide just perfectly lays out the two possibilities. On the left, you've got the protective path. That damaged stem cell is safely taken out of the picture. The result? A gray hair, sure, but a potential cancer has just been stopped in its tracks. On the right, though, is the dangerous path. If that safeguard fails, the damaged cell can start multiplying, which is a big risk for melanoma. So in this context, going gray is actually the win. Okay, so to really get what goes wrong, we first have to understand how the system is supposed to work when everything's going right. So let's take a quick look under the hood at the biological machinery that gives our hair its color. It's actually a really elegant four-step process. See, deep down in the hair follicle, these special stem cells get a signal to wake up. They then mature into these tiny little pigment factories called melanocytes. These factories start churning out melanin, which gets injected into the growing hair shaft, and boom, you have color. It's a perfect cycle that just repeats over and over again. Now, researchers at UT Southwestern totally nailed this down. They found two key proteins that work almost like two-factor authentication for hair color. First, you have a protein called KROX20. Think of that as the grow signal that tells cells to build the hair shaft. Then, those same cells produce something called stem cell factor, or SCF, which is basically the color signal. It tells the melanocytes to add the pigment. You absolutely need both, working in perfect harmony. All right, so now that we know how it's supposed to work, let's look at how it can all go wrong. The latest science has pretty much identified three main ways this whole intricate system can break down, and they all lead to gray hair. The first one sounds like it's straight out of a movie. A huge study from Harvard found that when you experience intense stress, your fight or flight response kicks in, and it floods your hair follicles with a chemical called noradrenaline. This chemical rush makes all the pigment stem cells activate at once and literally flee the follicle. And the crazy part? It's a one-way trip. They never come back. That depletes your color reservoir for good. The second path is, a little less dramatic, but it gets the same job done. Researchers at NYU found that as we get older, these stem cells can just lose their get up and go. They actually get stuck in one part of the follicle, so they can't travel to the area where they'd normally get the signal to mature into pigment producers. They're still there, they're just stranded, unable to do their job. And the third path? Well, this brings us right back to where we started, protection. This is that seno-differentiation process in action. When a stem cell's DNA gets damaged from, say, UV rays or just life, the body makes a tough call. It decides to eliminate that potential threat. This programmed self-destruction prevents tumors, but the cost, of course, is the future color for that hair follicle. So, those three processes are the core reasons hair goes gray. But some things can definitely put their foot on the accelerator. Let's take a look at what can speed up that journey to gray. Hormones are just massive regulators. I mean, just look at this. On the left, you've got a regular mouse. On the right, one that's been treated with a topical thyroid hormone. And the result is this incredibly fast, dark hair growth. It just goes to show how much power hormones have to stimulate the hair cycle. And of course, how any imbalance can mess it all up. And then, of course, there's nutrition. I mean, your hair follicles are little factories, and they need raw materials to make pigment. As you can see here, if you're low on key stuff like copper or zinc, the enzymes that are needed to actually synthesize melanin just can't function.
Without the right building blocks, the whole production line just grinds to a halt.
So, this all leads us to the million-dollar question, doesn't it? With all this amazing new knowledge, are we on the verge of making gray hair optional? Let's take a look at what the future might hold.
This quote from one of the lead NYU researchers is just incredibly exciting. It points to a really clear target. If some graying is just caused by stem cells getting stuck, well, then finding a way to get them moving again could be a direct path to reversing it. This is a huge, huge area of focus for new therapies.
But let's be realistic about where we are today. This slide gives us a good snapshot. On the left, these are our current options, mostly things like dyes or just making sure we have the right nutrients. But on the right, that's the exciting frontier. These are all things being actively studied, from drugs that could wake up dormant stem cells to therapies that activate specific growth signals. The science here is moving really, really fast. And that's where we'll leave it. We are right on the cusp of being able to potentially manipulate a really fundamental biological process. But all this new knowledge forces us to ask a pretty profound question. If going gray is one of our body's clever tricks to protect us from cancer, should we be trying to reverse it? It's a fascinating dilemma, and it's something we're all going to be thinking about as the science keeps moving forward.